Is my screen visible to you now?
Yes.
Perfect. Hello. Hey, Ramya.
Hi, Deepak.
So we can start at 12, right?
Yeah, we can start at 12 and welcome you all and have a nice time with our consultant, Mr. Deepak, on the webinar of DevOps.
Hey, hi. Hello, everyone. Good afternoon. So welcome to the webinar on DevOps by Varnaaz. So in our webinar, we are going to talk about DevOps. Before we start talking about our DevOps, let's introduce myself. My name is Deepak Gupta and I have close to 9 years of industry experience in the field of DevOps. Apart from that, I do have certifications over blockchain, Raspberry Pi, and big data cloud computing and CDN because DevOps is one of my primary areas. I presently work with Varnaaz as a consulting. And apart from that, in my previous roles, I have been working as a software engineer, as a DevOps engineer, systems engineer with Mintra. And then I was also leading a team of DevOps engineers with Movin Singh. So that's something about me. I do like to do some photography around. Some of the trainings or areas where I have delivered trainings till now are again revolving towards DevOps tools and technologies like cloud computing, AWS and Azure, container, Docker, Kubernetes, monitoring solutions, databases, both SQL and NoSQLs, web servers, messaging tools, configuration management, architecture, and a little bit of programming as well. So these are the areas where I do deliver trainings. Now, let's come into the agenda. We are going to talk about DevOps, but before we start with DevOps, we need to know why we need DevOps. So we start with Monolith, then microservices, talk about the issues with microservices, then take you to DevOps, and then explain you the tooling that we use in DevOps, okay? Yes, somebody's trying to fine. So as I'm assuming most of us are from the software background, and we know that we all have been developing things year on year, new systems. Guys, someone's WhatsApp is working. Can you please be on mute? So we always have been finding better ways to build systems, learning from our mistakes, how to build systems more stable. And we have also seen scenarios or witnessed scenarios where new wave of technologies came, they ruled over the millennia for close to 3 years, and then a new wave of technology comes. For example, Back in the year, say 2010, early 10 or sometime before that, Nginx came when it was a clear replacement for over Apache. And then big data came in the year 2010, 11, 12, and it was in a boom. Then 16 onwards, Golang came, and then sometime blockchain was there, but it didn't went through well. But then nowadays it's like Docker and Kubernetes are ruling the IT industry. So that's how a new wave comes and keeps changing the technology every 3-4 years. Now let's understand what's a monolith system before we start talking about microservices. A monolith system is basically a single tiered architecture where your entire application is interwoven into a single system. Your UI, your database, your IOPS, everything is designed on and deployed it on a single server. Now, when you deploy your things as a monolith system, obviously you have some pros, and the pros is that everything that you run is running into same application, so it's easier to debug and manage. You can easily hook up new components, and plus there's always a performance advantage because if all your applications are deployed on a single machine, they are obviously using the shared memory, and which is faster. Plus the network latency is also not there in the case of monolith systems. But the benefits of monolith systems far is less than the challenges provided by the monolith systems in today's requirements or in today's needs. For example, the first problem with monolith system is entire logic is deployed into a single machine, centralized server. It's a clear single point of failure. What if the centralized server goes down? If it goes down, our entire website business goes down, right? Second point is, with monolith system is it's typically very large and huge, and it requires a lot of team across geographies to write and maintain that large code base. Now, with that large amount of code base, obviously the developers becomes less productive. They are less prone to make any changes. The blame game starts like it's not my issue, it's your issue. People are very highly discouraged in making any changes. Plus, there's far more efforts required for orchestration, say for any change required or any deployment. You remember the late evening meetings or late night deployments? Yes, it happens with monolith systems. Now, even if a new guy is joining the team, it becomes next to impossible for the new developer to become familiar with the code, what is there if you have a large chunk of code. And automatically that guy is going to be less productive and he'll refrain from making any changes. The next problem is, say, you just want to modify a single line of code in your monolith application. So you have modified a small change, but now the entire application needs to be redeployed. Say you just have deployed your code 2 days back, your testing team did a brilliant job. They tested your application and now you found a bug, just one line change. Even though it's a one line change, but still it requires a lot of regression testing and all those things again, and it's a pain, right? And the biggest flaw with monolith systems is that it's a single dependency on one technology stack. Once you have deployed an application, there's no going back. You have to stick with that application forever. Now, given these problems, there was another solution that came that let's start migrating to the microservices architecture from monolith applications. Now, what is this migration from monolith to microservices? Just make this code base much smaller. Individual functionality to be provided by individual microservices. They work as a team. So now once you have a smaller code base, you just have a few guys responsible for managing that. So a smaller code base, few guys managing that, and that to be in a specific geographic location. Now this adds to the advantage that the design flexibility is easier. They can manage their source code very well. If there's any changes, development, they are readily happily to develop because it's a small code base and they know the in and out of the code base. You ask them to add a new feature, they'll sure be glad to add new features. And the best part is deployment is easy. They don't have to depend on other changes to wait for the deployment, right? So entire monolith application has been broken down into smaller chunks of microservices and decoupled. Now it's easy to scale, and now the communication between the different microservices starts happening either via REST API or obviously messaging queues like ActiveMQ, ZeroMQ, RabbitMQ, or Kafka, or any sort of solutions like that. Okay. So this is how a traditional monolith looks like. You have a monolith application where you have the UI, business logic, everything interwoven into a single component. If this component goes down, your stack goes down. And this is how microservices looks like. Say Amazon.com, any e-commerce website you can think of. They have the UI, they'll have different microservices. Say someone is from UI, someone is from payments, someone is from order management, someone is from logistics, etc. Now, even if one of the logistics management is down, your UI, your order management, and your payments will not fail. You can still, your website or your application is still functional to that this much capacity, right? Your entire website does not goes down. This is the benefits of microservices architecture, right? But at the same time, with these benefits that microservices brings into the hand, there are disadvantages as well. The complexity of the system also increases. It's fairly challenging to understand what's happening inside the system, how the messaging calls are happening. Okay, let's have a look again. Earlier it was only one system. It became easy. It's always easy for us in my monolith system to figure out if there's an issue. We can go ahead and look at the logs here. But now, see, in this scenario where you have multiple systems and say this microservices is being deployed on hundreds of servers. Now, if there's an issue, how many servers are you going to look into the logs? This has another 100 servers. This is another 100 servers. At the end of the day, it becomes next to impossible to figure out how to look around and manage these microservices. Okay. So this is the biggest downside. The challenges with microservices are how are you going to monitor the systems, especially with the advent of auto scaling where servers can come up when the load is too high, and by the time you wake up the load has gone and the servers are also gone. How do you start monitoring those systems? How do you start monitoring the logs if something goes down during auto scaling? How do you make sure the network latency is perfect between the respective applications? Moreover, now security is also a big issue because you have lots of moving components. When you have jumped into microservices, your deployments should be streamlined because in Monolith, your deployment used to be on a single machine. But with microservices, you may have to deploy a single microservices on hundreds of servers. And the last is testing. How do you start testing all your applications? Single application, unit testing, functional testing, those things. They also become so strict challenges are you have multiple servers to monitor, you have multiple logs to look through, and there can be multiple places where network latency can cause issues and you have to fix them all. Are we good till this part? If the same would have been done with Monolith, we just have always an obvious answer. If the website is slow, go to the single machine, it's the Monolith. Any errors, go to the single machine, it's the Monolith. If the CPU is packing at 100%, again, it's the same single Monolith server. In short, if a single point of failure is there, also investigation also becomes simpler, right? But that's what we didn't choose. We choose still to go with microservices. Now, this is the place where DevOps starts coming into picture. DevOps or DevSecOps are very interchangeably used nowadays, and even SRE as well. DevSecOps also emphasizes on focusing towards security. Okay. Now, if you're migrating towards microservices, do not even think about that if you're not planning to invest sincerely into DevOps, because microservices has got a lot of moving parts, auto scaling, log management, monitoring. So if you're not into that part, this can be a huge explosion of moving parts and we will not be in a state to manage all these things. It's never a good idea to implement microservices without we have deployment and monitoring automation. I'm sure you guys have seen it already in today's scenario. Most of the organization, even your organization would have been started working towards deployment automation at least, Jenkins, right? The next phase starts following monitoring automation, etc., etc. if that has already not been in place. So what deployment automation means here, you should be able to push a button and your application gets automatically deployed. And a higher level of automation means you are not doing anything, you're just committing your code gets automatically tested, the unit testing, system testing, integration testing, all testing gets done. And using the commit hood, the trigger is happening, you have created your Jenkins pipelines and your deployment is done without your intervention. Okay. Still, there are organizations that are capable of having this level of automation when they don't do anything, just push the code and app gets deployed. but they still prefer manual checks. Obviously, that's their business requirements. Okay. Is there any question? So guys, just one moment. I think there are certain questions.
Hello.
Hey Ramya,
Yeah,
guys, I'm
uh,
not.
this,
Yeah,
there are many people waiting. Can you just allow them?
how to do that? Please help me out.
Because you are a host, I've given the control to you.
Mm-hmm.
So they will just send you a request. You need to admit them.
I have not seen any requests, so please. I'm stopping my screen share.
Okay.
Please ask them to send a request. Okay, admit all. Yes, I
You
got
did
it.
it? Yeah.
Yeah, I have to disable my screen share. Then only I'm able to add them all.
Yeah.
Is this fine now?
Yeah, fine.
Okay. I'm sharing my screen again. Okay, so yes, then how do we define DevOps? So DevOps is more or less not a role kind of thing. Yes, people do use it as a role. That's perfectly fine till some point of time. But nowadays the tradition is again changing and the role is being defined as SRE. So DevOps is more of a set of practices that you do, tooling practices. You have a set of concepts like how does networking works or how does your cloud infrastructure. You practice some tools in a structured way, and you are able to respond to issues or new features in a very quick way.
Hello.
So organizations that have already adopted DevOps are far more easily able to release their features and monitor the metrics, and they are even able to quickly respond to new requirements or new features, whatever happens in
Is it
production,
Deepak?
because the
Hello.
framework is already set and streamlined.
Hello.
Yes, Rajiv, you are not very loud.
Hi,
Can you please be loud?
Shivani.
Hello. Am I audible, Deepak?
Hello.
Hello.
Yes, guys,
Yeah.
just one moment, please.
Deepak, I think you have just allowed me to join us. Repeat the session again.
I guess repetition may be difficult at this point because we have started with DevOps right now only.
Okay.
The rest, everything was just introduction kind of thing. Okay. So, yes. So, Ramya, we are continuing from here.
Yeah, it's okay.
Yeah, sure.
Okay. Fine. We are able to, with organizations who practice DevOps, are obviously able to respond quickly to new requirements, which is happening in production or new issues, because they already have the necessary infrastructure and their structures in place. So this is not what we call as DevOps, when people are sitting at the area while few are firefighting for the issue. No, that's not what we call as DevOps. DevOps is what we call as a common mindset where everyone joins hands together to achieve a common goal. We don't say that it's your issue or it's our issue. Ideally, obviously, there is a barrier at some point of time, but generally we treat things as an organizational goal. So DevOps always talks about development plus operations, where if you are a developer, you have a basic understanding of operations and you write your code have with understanding the issues that your application can have when deployed to production, while operations guys will provide the feedback to the developers as well, that yes, these are the feedbacks how the code runs in production. You can try using such certain patterns or certain techniques. Now, once this cooperation starts happening between the development and the operations team, the final result will be an organization which has people working towards a common goal. And then the organization is leading to success. Okay. Now, DevOps is mostly towards business values. It's obviously meant to increase your production flow by reducing friction between the teams. No more firefighting or emails that it's your issue, it's not my issue. You reduce the friction. You figure out, okay, it's our issue. Let's figure it out. This is my area. I think I fixed it. Maybe you need to have a look and fix it, and I'll support you. So it's more kind of reducing in friction, and because of reduced friction, the risk reduces with your product, and your product quality increases because both the parties, the dev and the operations, are aware about what's happening, right? Now, this DevOps also follows certain process like agile practices, the standard that we were always using. With agile practices, they define their work, then continuous integration. They figure out how to integrate their code and how to release it in an automated fashion, and that is release automation. And once the release has been done, how do you start testing it? That is functional unit testing and system integration testing. And once the testing has been done, how do you deploy it to the production? And after deploying it to the production, have a general feedback mechanism and figure out how your service is working and infrastructure is working using some monitoring solutions. Everyone good till this part?
Uh, Hi, this is Babu. I just had one doubt. As a developer, I'm developing the code. Then immediately,
Yeah,
after
Babu.
review, after review, I'm just checking
Mhm.
the code. So it is going into RM team. They're going to make the build, right? So I try to understand how it is interacting with the operations, because you in the
Right.
earlier slide you showed development plus operations, right? So I'm clear with the development process and the release process, but I'm a bit not clear with the operations side, how it is handshaking with the DevOps. If you possibly, is it possible to give one example to understand from my end?
I'm giving you an example. Have you
Yeah.
implemented circuit breakers?
No, no, no. I'm basically I'm not a developer actually.
No,
So I
no.
tried.
Developers implement circuit breakers. It's a timeout mechanism. When you're trying to make a call to a REST API,
Okay.
you have to wait for a certain time. If the API does not respond to you within 5 seconds, 3 seconds, then you return a 404 error,
Yeah.
right?
Yeah. Yes.
Right.
Yes. Yes. Yeah.
So this is one of the very basic examples how you start looking at it from the production scenario as well. So you don't keep on waiting forever for the calling API that you have called to respond.
Okay.
Right. This is one thing. Then you also have to think about scalability, how things work, or if you have a team where you sit down with your deployment guys, okay, how is the deployment streamlined, how it should be working, or is your application able to take care of dependencies all by itself or not?
Okay. Okay. It's more of a release activity, right? Release and deployment activity, right?
Yes. See, that is the boundary between developments and the operations. That is the boundary where both hands meet.
Okay. Okay.
Mostly towards the continuous integration, release automation, and some part of testing.
Okay.
Okay,
Yeah.
but monitoring etc goes completely towards the operations guys.
Okay.
Okay, while coding is development, monitoring is operations. In the bid, this is the boundaries, CI/CD pipeline and release automations where both developers and operations meet.
Okay.
Okay. Now, some of the tools that are present in the market which we use for our DevOps are not limited to these tools. These tools are obviously free open source tools. There are enterprise grade tools that maybe your organization is using. Again, it depends on your business use case, but the de facto industry standards in open source world for monitoring are Nagios, Zabbix. These two are the biggest players in the monitoring world. Then we do have Isinga, Sensu, Cacti, Datadog, etc. For configuration management, that we'll talk in some time. It's Ansible is one of the de facto standard nowadays. Although Puppet and Chef have their own places in scalability, and SaltStack as well is coming good. Then we have SQL databases like SQL and SQL. There's nothing that we don't know in this part. We have been using this for quite a long time. Apart from that, we have Microsoft SQL and SQLite as well. So the NoSQL data stores that are very much famous in the world of DevOps is Cassandra, MongoDB, DynamoDB, and Cosmos DB. Everything DB was a bit famous, but then it's slowly coming down and lose its charm. So Cassandra is still taking the place, and Mongo is also doing great. Build and release. I'm very sure most of you are already working with Jenkins. Jenkins is the de facto. Around 90% of the industries are working with Jenkins. Others also use Circle CI, while Oracle is providing with Hudson. Then apart from that, we have cloud-based services like AWS, Azure, Google Cloud, Linode, DigitalOcean. They provide the cloud infrastructure. And then we have platforms that organizations use to deploy their own virtual machines or infrastructure like OpenStack. Developers, sysadmins, or DevOps like us, we use Vagrant on our local machines to spin up virtual machines. And we do use Heroku to test our applications, sometimes free of cost. Docker is used for containerization that I'm going to explain you in some time. Apart from that, the programming languages that I use in DevOps are Bash, that shell scripting, and is not that great, but it has been quite some time in the market. And log management, Elasticsearch, and Solar are the de facto standards. Scribe was a solution developed by Facebook, but has now become obsolete since 2012. There are companies that are still using it, open source, and I have seen it scale to up to 2 million log lines per second. It's good. Heka is a solution developed by Mozilla for log management. So these are some of the few tools present in the market that you can look for as DevOps tool set. Okay, let's start exploring some of the tools and see what they do. So first is cloud providers and load balancers. So the standard cloud providers are like AWS, Azure, Alibaba, Linode, DigitalOcean. Now these are our internet. That's the best explanation I can give you for cloud providers. You can spin up servers, you can spin up load balancers, you can have public IPs, everything you want, you can get it done within 5 minutes from these cloud providers. It's a pay-as-you-go model. The standard load balancers that we have here is, say, there's an end user who's trying to communicate with your services deployed inside your private network or in your infrastructure. Now, what you do is you create a load balancer, and the load balancer is actually pointing to your private network or infrastructure. So only the load balancer is going to have the public interface exposed to the world. So all the users are going to send requests to the load balancers. The load balancer will be managed obviously by your cloud providers. Okay. And the load balancer is responsible for routing this request to the servers behind your load balancer in a defined algorithm, round robin, weighted, or whatever way you define. Okay. So that's about load balancers. Let's start talking about Git. When we start talking about development, everything starts from the Git. Because Git is a version control system. Guys, am I audible at your end? Hello?
Yeah.
Hello?
Yes, yes, yes.
Okay, fine. Git is the source code management. Okay. Now, so when I say source code management, say I'm developing a piece of code today and it will take me say 2 months. Tomorrow I made another new changes, day after tomorrow again. For continuous 2 weeks I made changes. Then I figured, okay, the second day change was the best. Let's go back to that. If I have not used any source code management, there's no clue, there's no way for me to understand what I wrote in the code just to on the second day. Right, unless I start managing individual files for every day, and it obviously becomes too much cumbersome. So the source code management standard tools are SVN, Git, IBM, ClearCase, etc. So Git is taking a clear lead over all. Hello.
Ramya, you're there?
Yes, sir, I'm there.
Ramya, I think he has lost the connection.
No, I'm here.
Deepak is there.
Oh, Deepak is there. Okay.
Okay, from where did you miss?
No, the screen is not shared, I think, or
Is it shared?
oh,
No, we are not able to see it. Deepak.
we're not able to see. And I think you are not the host now. Ramya, you have to transfer the rights to Deepak.
Yes, sir, 1 second.
Yeah.
Yeah, Deepak, you can share right now.
One moment. So hey Ramya, is it fine now?
Yeah.
So I was talking about Git. So the Git is a source code management tool. It's a replacement for ClearCase and SVN because it is fast. So to understand about Git, there is a book that you can always refer or try to refer with Google. We're going to give you an overview of Git. Function or SVN is good, but Git is still better because you can commit as much as you want because you always have a local copy. So, and in Git, everything is distributed. I'll show you in the diagram next. Branching is very cheap in Git. You can create as much branches as you want. You can admit as much branches as you want. That's perfectly fine. Your Git is fast. Your data is always secured by some checksum, and you can always figure out the history. Let's see how it works. Git works in a distributed control system, and it's an open source solution. During 90s, Linus T. Torvalds was writing his kernel development. At that point of time, he found the traditional tools or version management tools not very great. So he started writing Git at the same time during his kernel development, and it's written in C programming language, and it's an open source as well. And at this point today, while we are talking, it's being used by lots of, approx 80% of the projects are migrated to Git. Please do remember, Git is not GitHub. Git is a server, while GitHub, Bitbucket, or GitLab, they are the hosting solutions where your data is actually present. But how to make meaningful or sense out of the data is done by Git, which is a server. Okay, Git is not Stash; it's very different. It's free, open source, distributed, and you can always use it. It's very efficient, written in C programming language. So this is how it works. Git, say all the contents in Git, all the commits that you do, it's all protected by SHA-1 checksum. The history in Git are always managed by keeping relations. Okay, this is the relation. This is where some new changes were made, some new changes made, and then it was merged here. So this is how the merge history is being taken care. And Git is very fast because Git uses snapshots and not differences. Very important. This is how the traditional infrastructure looks like for any centralized systems, and this is for decentralized systems. In centralized systems, your commit always goes to your centralized server. If this server is down, you cannot continue your work. But with Git, every user has their own local server. Now, every guy has their own copy and they can continue working even if the centralized server is down for some time or whatever it is. So once the work is done and the centralized server is back, they can again push the changes to the centralized server and others can take the pull. So essentially your work never stops with Git. Now, why Git was faster? I spoke that Git takes snapshots, not file differences. Yes, somebody was speaking. Okay, no questions? Git is faster because it takes snapshots and differences. Because creating difference of two files is a performance intensive task. Like this is how SVN or ClearCase 2 file A, version 3, 4, 5 for file A. In version 2, there was some change. So this is how the delta is represented. Now another delta is represented. Now say you want to do some activity, figure out the difference, etc. Then with respect to your file, the delta will be calculated. That is a task. That is performance intensive. While what Git does is, if your version 1 for A is A here, version 2, if there is any change, Git will store the complete change as A1. In version 3, it will store as again A1, no change. Version 4, if there is change, it will again store the entire snapshot as A2. Please don't misunderstand this as Git takes more space. No, Git takes in algorithm even okay, that's why Git is faster, and this is how Git stores things in it. That's all about Git. Let's start talking about Jenkins. Okay, now Jenkins, as we all know, is a continuous integration tool. It's completely written in Java. It's one of the de facto standards in the industry today for CI/CD, continuous integration and continuous deployment. So Jenkins was actually always a part of Hudson. It was running free of source. So after Hudson was acquired by Oracle, there was a dispute about the releases between Oracle and the actual Jenkins developers. So the developers took a fork of open source Hudson and created their own product called as Jenkins. So today we have two products: Hudson provided by Oracle, not free of cost, and Jenkins provided as open source free of cost. So it's a server-based system. It's where your application is running as part of serverless container. You run it in Tomcat, Jetty, it's your choice. So the Jenkins can monitor execution of your jobs. The jobs can be of deployment of your application, doing some cron jobs, any batch activity, database migration, backups, or anything. Jenkins can take care of that and manage as well. So let's say have a look at what is continuous integration, continuous delivery, and continuous deployment. Okay. Now, when you write, say, your Java code, you do a build. From that build, you get your artifact, say jar or a var. Now that jar or var automatically gets tested, and unit test is done. Unit test, after that, it's automatically deployed to staging, and then automated acceptance test is done on your application artifact, that is jar or a var. This is what we call as continuous integration. Now, the continuous integration plus deployment to production in a manual phase is called as continuous delivery. Now, continuous delivery, when achieved via automation, is called as continuous deployment. So now we understand what is continuous integration, what is continuous delivery, and what is continuous deployment. So let's see why we need Jenkins again, because the world is distributed one. Our systems are not a single monolith system now. We have a lot of systems, 100 servers, remember? Now, with those 100 servers, we may want to deploy it only on the first 25 servers and monitor how it works and gather the feedback and then deploy it to the next 25 and gradually deploy. All these things can be achieved using Jenkins, plus obviously some sort of configuration management tools. Okay. So this is how the entire flow works. A developer is working on his machine. His code works very good. He pushes the code to the repository, say Git or Microsoft TFS. Now, the moment you push the code to Jenkins, once the Jenkins gets triggered as part of the jobs that you have already configured, Jenkins is going to grab the latest piece of code, build it. It will build an artifact. It can be an exe, website, application, jar, var, Docker image, whatever it is there, the artifact. And then it will run test on your artifact that can comprise of NUnit and Gradle, anything else. Then it will deploy and push to live server. And once your application gets deployed to the live server, your customer can start using it and he'll start reporting the feedback. And the feedback again will be passed to the developers and the operations guys. Okay, this is how the application is working. Some more changes needs to be done, right? This is how Jenkins is going to fit into our. That one thing that we should understand before we start Jenkins and source code management is that Jenkins and configuration management tools like Chef, Puppet, Ansible, or Salt, they go hand in hand. They cannot be separate things because you always need to have consistent environments. Jenkins is going to run the jobs for you, but Jenkins does not have the capability to manage servers by its own. It needs to use some kind of configuration management tools that we are going to talk next. Okay. So let's see that. We're going to talk about Ansible as the configuration management tool. So this is how a typical day looks like for a DevOps or a sysadmin. Okay. Someone says something is not working. Someone says license failed. Someone says unexpected error with his applications. Someone says I cannot deploy my application because certain user not found, somewhere password is wrong, it has to be reset, some application is not installed. So a developer, a DevOps or a SRE or a sysadmin has to 10 things a day, which manually is possible. It's dedicated, you can also 50 servers manually, but if you say 5,000 servers single day, no one can do. We need to have certain sort of automated mechanisms. Here, Ansible comes into picture. It's a software platform for configuration management of systems. Other systems similar to Ansible are Chef, Puppet, SaltStack, etc. that manage systems, that can manage thousands of systems, create users there, install some applications, and do a lot of things. So Ansible is agentless. It does not require any external software. Ansible is secure because it uses SSH. Ansible is scalable because it just uses SSH and nothing else. And the best part about Ansible is it's very easy to learn. We can start learning Ansible in just 2 hours, and within one day you can figure it out that you have become near to expert in Ansible. It's so easy to learn. Now this is how Ansible works. Say this is your centralized Ansible server, and with this Ansible server you're trying to manage development servers, say 100 servers here, 50 servers in QA, 10 servers in UAT, 1000 servers in prod. All these servers can be managed by a single Ansible server, where in the Ansible server you have to define the host inventory, that is what is the IP of the servers here, IP of the servers here, and then what are you trying to execute here, or what do you want to execute on this server, say creating a file. Guys, one moment, I think some more people have joined. So, okay. So we're talking about this single Ansible machine can manage the servers inside dev environment, QA, UAT, prod, etc. Right? So they can manage this by providing the host inventory, IP address details of these machines here, servers here, and the servers in UAT and the servers in prod as well. Inside the playbook, we write what do you want to execute here. Say we want to create a file, we'll write it into something .yml format. Ansible uses .yml file to write instructions what you want to do. It's very simple. Now, what we do with Ansible, we can do package installations. We can execute shell commands on a lot of remote machines, say 100 machines at some time. We can install or update softwares. We can manage systems. We can do a git clone of our repository. We can start, stop, restart services, and a lot more things we can do with Ansible. In short, we can automate all the things. So that's all about Ansible. Any questions with respect to Ansible or its functionality? And then I'm going to talk about Docker and Kubernetes. Okay, the standard problem across all organizations, the software works on my machine, but does not work on your machine. It works locally, but it does not work in a testing environment. It works locally, but it does not work in the production environment. And there's a lot of heated email exchange and never ending arguments. The developer is blamed and whatnot. The operations guy is blamed and the friction increases. How many of you have seen this? We can write it on the chat, right? So this is the common scenario. Let's see how the VM works, and then I'll talk about how the containers work and what are the containers. VMs are essentially virtual machines. They work on hardware. So this is your base hardware or whatever server you have, on top of which you install operating systems like Windows or Linux or kernel. Then you have a hypervisor like VMware Workstations or Oracle VirtualBox. And then finally you start running your virtual machines. And inside your virtual machines, you are deploying your applications, correct? But the problem with this approach is the virtual machines themselves will need a minimum of 2 GB RAM because the guest OS also needs to run, correct? So we are wasting 2 GB minimum on these things, and plus it's huge resource constraint. The same when we do with containers. So you have a server, you have a single host operating system. On host operating system, you install Docker, just like you install JVM, and on top of JVM, the applications run. Similarly, there's a Docker engine running. On top of this Docker engine, there are multiple containers running. The difference between the VM and this Docker approach is these containers do not have their own kernel. In fact, they utilize the same host operating system kernel. That makes these containers lightweight. So that means here in this scenario, where the guest operating systems consume 2 GB each, the containers are sitting at 2 GB here because they're utilizing the same kernel as the host OS. And that is why containers become lightweight. It's more or less the same as VMs, except that the architecture wise containers use the host OS kernels and hence they become lightweight. Plus, containers can be deployed on physical machines or virtual machines. They don't actually need the actual hardware. They are a virtualization at the process level. So this is how Docker containers runs. Say you have a system or you have an operating system on a VM or a physical server where you're deploying your application 1, you're deploying your application 2, you're deploying your service 1, SVC 1, and you're deploying your service 2. All these are running on top of this Docker process. So any other guy can reach these applications and say this is a UI, they can access the UI, work with the application, and you're not wasting resources with Docker. And the best part is it works on my system, it does not work on your system, gets resolved, because in the world of Docker, our developer, once his code is working fine, he'll create an image. The image can be thought of a template. Okay. Now, on that specific, they can run multiple containers like this, app1, app2. Think of the old days when we used to have a Windows disk image, and say from the same Windows 98 or Windows 2000 disk, we used to install it on so many systems, the same single disk, but we are running so many systems from the same disk. Similar way, a developer will create an image, and the same image can be used to create multiple containers. And if the image created by developers works fine on his system, it is bound to work fine on the production or in the dev or pre-prod environment as well, because the container takes care of all its dependencies. Okay, that's the problem Docker is trying to solve. And how Docker works? Docker works something like this. A developer is going to create an image system. Okay, there's a container. From the container, once he's verified, he's going to create an image, and he's going to push this image to some registry. Just like we push our code to some repository like GitHub or Bitbucket, Docker has call it as registry. So these registries are like on-premises Docker trusted or hosted Docker registry, or Docker Hub, Azure Container Registry, and many more available. Just like we have Bitbucket, GitLab, etc. Docker also has registry. Now, once the Docker image has been pushed to registry, a testing team can pull the image from the registry and start running containers from them, and it will work. Any questions here? Okay, let's rethink Docker in a very beautiful manner. Somewhere on the internet is explained as explain Docker to me as I'm a 5-year-old. So think of Docker images as blueprints. For example, from the Docker images, you can create cows. Okay. Now Docker daemon is like of a coral where the cows can run. Okay. Now Docker Swarm or Kubernetes is like a shepherd or a rancher who is going to manage the cows. Let's see what it happens. From the Docker image, we create many Docker containers. Think of the cows, okay? And let the cows do their thing, whatever they are supposed to do on the Docker, on top of Docker daemon. So here the cows are supposed to eat the grass. That is, they are going to consume these resources. Now, the problem here is the moment more and more containers get created, that means it is getting crowded, and the containers starting stuff around, that is RAM and the hardware, which you call it resources. In this diagram, the cows start eating all the grasses, right? So what is the way we can do to save the grasses? We can distribute the cows to other areas where they can start consuming the resources or eating the grasses. Otherwise, once all the grasses are consumed here, the cows will die. That means once all the resources are consumed, the containers will no more be able to run. Right? So what we're going to do, we hire a rancher called as Kubernetes and tell him where are the other fields where the cows can go and eat the grass. That means we tell the Kubernetes where are other nodes where the containers can be deployed so that the containers can use the resources. Now the Kubernetes knows where are the fields or where are the nodes, and Kubernetes will guide these containers or guide these cows to those specific fields so that the load can be evenly distributed. Okay. So the Kubernetes will work as an orchestrator or it will take care of moving the containers of the cows when the resources are low, and the Kubernetes will be responsible for optimizing of the resources as well. So this is in a very short nutshell information about what is Docker and what is Kubernetes to Docker. Is there anything I can help you with Docker and Kubernetes here? Because next I'm going to talk about ELK. Okay, no questions. If you have any questions, you can always ping it on the chat window. Next, we're going to talk about ELK and Nagios. Now, Elasticsearch. What is it actually? It's a search and analytics engine. That means we can search something on the logs. Say you try to put an order on Amazon.com at say 8 p.m. 8 p.m. is the peak time in Amazon.com, and they have done auto scaling. So that means they have provisioned additional 50 servers. They already had 100. They provisioned additional 50 servers. Now, when you placed an order, your order got served by server number 121. That means the new server. Now, your order failed somewhere happened, and your order failed, and your amount has been deducted. Now, you raise a complaint to Amazon. But by the time you raise a complaint, the server will stop because I have no figure out. So here Elasticsearch comes into picture. The moment server 121 was serving you the request, it was also logging certain details which gets pumped to a centralized location. So all the logs go to centralized location, from where once you raise a request, people can figure out your request ID and start doing the analytics and see what actually happened in your request call. Okay, this is the tool Elasticsearch, and alternatives are Solar that can be used to do your search and analytics thing. Elasticsearch is written in Java and it's completely open source, and it's being the core engine, or that is being written over Apache Lucene. It's a technique of sorting. Even Solar is also written on Lucene only. First release was in the 8th February 2010, and it can be deployed on any operating system, Windows, Linux, no problem. Okay. By default, Elasticsearch is distributed in nature because it goes for obvious reasons. There are organizations which generate up to 15 TB. 15 TB is a very less number actually. 15 TB of logs per day. Now imagine yourself looking into those logs. This is Elasticsearch is being used by large companies like NASA, Wikipedia, GitHub, Mozilla, and whatnot. Do you think it fair chances that they are using Elasticsearch? If not, then they are using Apache. Now, why ELK? The traditional old way was to do a grep or do a stream editor operations or AWK, cut, sort, etc. and manually look into the output, writing complex scripts. Not a very good idea when you have TBs of logs to look for. ELK stands here where you can define endpoints, input, output, you can define patterns, store data, you can search, you can start even doing visualizations as well for, say, a certain pattern is coming too much, right? It can happen, it can help you allow and collect the data, centralize it for better monitoring, understanding what happened. You can parse the logs, you can index it to quickly search the logs, say 15 TB each day, that means close to 450 TB in a month. 450 TB of data you want to search very quickly. Without indexing, not possible. You can do indexing here. You can visualize the data to do a lot of analytics. Say, for example, a very good use case, we need to operate a site which has very heavy traffic. We need load balancer and 100 web servers behind it, running behind the load balancer. We're using storage solutions, MySQL, and web servers which are putting the logs, okay? Now, the problem is there are mixed log structures. There's no universal log structure between your web applications, right? The log structure formats can differ and your searching becomes extremely difficult. MMDD, someone can use GD, MMYYYY, and based on time. Log locations and access. Sometimes the logs that you are interested into can be on different machines and on different locations. Now, that is also a very big challenge. So these things are being sorted out using Elasticsearch, right? So yes, this is, say, you're getting certain data like this. You're doing an access log of Nginx tail access.log. You're getting like this. and this is how you're getting it from the UI. Which one do you like better? Which one helps you make sense? Obviously the graph one, right? You can see, okay, this red is too much. Let's see what is red. You can look into the legends and figure out, okay, this is happening. Click on the red and then start further drilling down into issues, right? But then why do you need a search engine? Okay, this is why you need a search engine. 450 TBs of logs and you have to do some search operations. Your customer's payment failed and you need to provide him with a resolution. So you need a search engine properly planned, because search is how we find stuff, right? You're trying to look for Perl, you got the repositories and figure out, okay, these repositories have this keyword as Perl. Okay, now how does search engine works? Now that's a magic that we're going to talk about when we start on an ELK in detail training. Someone is talking. Okay, so magic is this. The magic here with search engines is inverted index plus relevance scoring. More details once we start any course on ELK. We'll be talking on that. Till that, this is way too technical to start to entry with. The last topic for today is Nagios. This is a single slide. So having said, we have the infrastructure, say with 5,000 servers and deployed our applications. Now we need some kind of UI to do a bird's eye view of all the infrastructures, which is working, which is green, how much is red. So we can utilize certain monitoring solutions. Nagios is one of the biggest players in the industry for monitoring, but there are other players as well. Say Zabbix, Prometheus for containers and Kubernetes. There are Sensu, Singa, and many more. Datadog depends on the choice. Which platform do you prefer? So Nagios is one of the platforms that we are providing as part of the course outline. Obviously, all these things can be customized to the tools and toolings that you may be interested into. Okay. Now, final thoughts, concluding thoughts. If you do like this demo and want to proceed with more information, do get back to us at info@varnaaz.com, or you can call at this number 903-501-3640. Okay. Thanks everyone for being in this webinar, and I'm open to questions for the next 5 minutes.
Yeah, Deepak, I'm there. Hello. If any more questions, you can ask our consultant, Mr. Deepak, related to the questionnaires in DevOps you would like to get clarified.
You can also put up your questions that you see in your organization, and you can ask me questions how DevOps is going to help or anything. It's basically AMA, ask me anything. I think I got something on the chat. Okay, there's a very sensible question. Two questions from Rajiv. How do we create tasks and assign to the resources in DevOps? How do we create tasks? Okay, say we had via Jira. Okay, priority tickets obviously we used to solve without Jira and later create a task for that. Now the task when used to get created, we every day used to have a 15-minute stand up and decide what are the tasks, what is happening in the infrastructure, what can be done. And based on the availability and work-wise, we used to divide it across multiple team members. And if there's a new team member who is new to DevOps or who's learning, he used to be under shadow of, say, for 1 to 3 months, depending on his comfort. I hope this helps you, Rajiv. Okay. Okay, then there's a question from Anadi. While you talked about various tools, how will you divide the time of the course for these modules? Anadi, there are basic divisions. Like the day one, we start with, it's a 5-day course, generic, that we do. It comprises of Git, Docker, Kubernetes, Jenkins, Selenium, and Nagios over the period of 5 days. Okay. If you need more details, just let Ramya know. We can send you the course outline. How do track change management? I'm not very clear, Rajiv. What is this? How do track the change management? Okay. Please suggest the best continuous integration tool by Prashant Raj. Um, Nothing beats Jenkins. It's the de facto standard. It's a golden rule. If you're new to that, go with the industry standard. And once you start getting comfortable, and then you start looking out if you still need to look out or not. Okay. Any more questions you have? Like if the task is transferred to another resource and the progress evolution. Okay. There's a question from Rajiv. If the task is transferred to another resource and the progress evaluation, that can be with respect to your management, because every task has got a major challenge part. Most of it will be honeypot. There would be one challenging part if that is completed or not. That is something that goes deep down to management part. Okay. There's a question from Prashant Raj. How about CI tools? I think the CI tools we spoke, it was Jenkins, Sagal CI. Why? Do you think it's a challenge with Jenkins, Prashant? See, Apache, I think, is a foundation. There can be specific tools for Apache, which I may not be aware of. Any specific tool you are looking for? I'm not aware about Apache Gump. There may be tools, many tools in the market, but the point is what fits your business requirement, right? Your question is answered, Prashant. Any more questions, guys? Okay, there's a question from Rajiv. One last query is on functional side. Like, what all activities does the functionals be able to do on DevOps? DevOps is like the Swiss knife of an organization. Functionalities, you can define it. If you have a Swiss knife, what it can do for you, life saving. Whatever things is required for the life saving of the organization for fast paced deliveries, each and everything needs to is a part of the DevOps, or at least your project. Because DevOps differs a lot when you talk about DevOps in startups, and DevOps has a very different definition when we talk about DevOps in enterprise organizations. And then guys, as promised, it's one and it's time we close the session. Ramya, it's over to you. You can take the control and
Yeah, thank you, Deepak. Thank you everyone to be a part of this demo webinar. Shortly, we'll be sharing you the course content and the program. For 5 days it has been. So we'll share you all the details through email so that we can have a one-to-one call discussion for further updates.